the asteroid belt. The asteroid belt is just what separates, is just a rocky debris that separates the Mars and the Jupiter. That we also mentioned in the last class. So we are now going to look at the Earth, the structure of the Earth. We are going to look at the internal structure of the Earth. So may I project now? So in the 20th century, it became obvious from seismic waves, when seismic were sent into the Earth, the waves or the signals sent into the Earth result in shaking of the Earth. As a result of that seismic wave being sent into the Earth, it revealed the structure of the Earth as being radially structured. So the Earth is radially structured, and that is similar to that of an onion. Just imagine yourself taking an onion and cutting the onion with a knife. You are going to see so many layers which are not visible when you look at the onion as a bunch or as a whole. But when you now take a knife and you decide to cut the onions vertically, you will see so many layers of the onions. As radial as those layers of an onion is, that is also what seismic wave reveal as regard the internal structure of the Earth. So there are boundaries from one layer to another layer, and because there is an abrupt change in the velocity of the seismic wave, it is telling us that we are moving from one layer to another layer, bringing into fore the knowledge of refraction that you have. You recall in your physics, when a wave moves from one layer to another layer, because of the difference in their optical property, there is going to be a change in the direction of that wave, leading to refraction. Because there is a change in the direction of the wave, there is a change in velocity. That velocity change is caused by difference in the optical property of that medium. That is in terms of optics. In this case, the optical property we are going to look at, or that is responsible for that change in seismic wave, is what is called density contrast. So the density contrast from one layer to another layer make the seismic velocity to change from one boundary to another boundary. So the boundaries between the layer are marked by abrupt changes in seismic velocity or velocity gradient. Why are we talking about velocity gradient? If we look from the surface, from the center of the Earth to the surface, there is variation in distance. There is variation in distance, as we are going to see. So because of that variation in distance, we can talk about velocity gradient, which is just the difference in velocity between two parts divided by the separation between them. That is what we call velocity gradient. So the boundary between the layer are marked by abrupt changes in seismic velocity or velocity gradient. So each layer is characterized by a specific set of physical property determined by one, composition. So each layer, we are going to see the layer that make up the internal structure of the earth. Each layer is characterized by some specific physical properties. What are these? And these physical properties are determined by the composition. What are the chemical composition for that layer? What is the pressure within that layer we are looking at? And what is also the temperature? So these three parameters determine the characteristics of each layer. The composition of that layer will determine the physical property that you can get within that layer. Also, the pressure difference from one layer to another, as well as temperature difference. These three parameters will determine the characteristics of the physical property of each layer. So this is what we have. This is showing the earth. You will now slice the earth. If the earth is now sliced into 4 parts, if the earth, imagine yourself taking an onion, now take a knife and cut the onion into 4 parts. Each part will give you a quadrant. Each part will give you a quadrant, or what you call a sector in mathematics. And this is a sector of what you are going to see. So we have sliced the earth, and from what we have sliced on the right, we can see that the earth is actually made up of 4 layers. The earth is actually made up of 4, but some call them 3 layers. If we want to call them 3 layers, it means that we are referring to layers as one. So the 4 main layers are the crust, that is the outer part of the earth, the mantle, then the outer and inner core. If you want to call them 4 layers, then the core must be divided into outer and inner. If you want to say there are 3 main layers that made up the earth, then you simply say the crust, the mantle, and the core. So the crust, the mantle, and the core. It means you have grouped the outer core and the inner core, you have grouped them as one. So this is the section, this is a 2D dimension of the earth. This is a 2D dimension of the earth. After we have sliced the earth in this manner, that we represent it with a quadrant, if we now decide to stretch it, if we decide to stretch in 2 dimensions, we now see it as a rectangle. It is seen as a rectangle in this manner. So on this vertical axis, we have the depths. We have the depth. And the depth ranges from 0 kilometer to over 6,000 kilometers. From 0 kilometer to over 6,000 kilometers. So what are these compositions? We have the crust again. Between the crust and the mantle, we have other layers such as the lithosphere. Then we also have the asthenosphere. The mantle can also be grouped into the upper mantle and the lower mantle. So now, at depth of a few tens of kilometers under the continent and less than 10 kilometers beneath the ocean, seismic velocity increases. So we have the continent as well as the ocean. Why do we have the continent and the ocean? We are going to see what they represent. So there is a region where there is discontinuity in seismic velocity. There is a region where there is a discontinuity in seismic velocity, and that region lies between the crust and the mantle. That region where there is discontinuity in seismic velocity, that region or that boundary lies between the crust and the mantle, and that region was named by a Romanian geophysicist or scientist, which is called Mohorovič. And that happens in 1909. So Mohorovič now called that layer where there is discontinuity Mo-O. We can simply call it Mo-O. Mohorovič was a Romanian scientist in 1909 who discovered the boundary between the crust and the mantle. He discovered the mantle, he discovered the boundary between the mantle and the crust. So you simply call it the Mo-O. So it's always a discontinuity. Yeah, one. And there was a slight break. So that is what we call the Mo-O. So Mo-O is just the interface between the crust and the mantle. So what do we need to know about? It's just lead to a discontinuity. There is an abrupt change in velocity. And that region, there is velocity is increasing, and all of a sudden there is a drop in velocity. By the time you get to year 3, year 4, under seismic, you are going to learn about what we call velocity inversion. You will learn about velocity inversion. So that region where there is an abrupt drop in the seismic velocity is what we call the Mo-O. So that is called the Mo-O. It usually occurs between the crust and the mantle. So the crust and the uppermost mantle down to a depth of about 70 to 100 kilometers under depth ocean basin, and between 100 to 150 under the continent is rigid. So when we look at depths between 70 to 100 kilometers, we are talking about the ocean basin. Then if we go beyond 100 kilometers, between 100 to 150 kilometers, we are talking about the continent ridge. So forming a hard outer shell, which is referred to as the lithosphere. So you can see the lithosphere there. You can see the lithosphere. So beneath the lithosphere lies the anthenosphere, a layer in which seismic velocity often decreases, suggesting lower rigidity. So the asthenosphere play an important role in plate tectonics. In the last class, I told you about the plate tectonics. The plate tectonics is one of the evidences that we give that the universe is actually expanding. You have all the continents moving apart, the Asia, the Africa, the planets are moving apart, or the continents are moving apart, One of that evidence, an evidence that shows that these continents are moving apart, is the plate tectonics. You are also going to take that in some of your courses in geology. So it plays an important role in plate tectonics because it makes possible the relative motion of the overlying lithospheric plates. So let us now look at each of the 4 regions that we have. The outer part we said is the crust. So what do we call the Earth's crust? The Earth crust make up only 0.5% of the Earth's total mass. So you can see that the Earth crust, it made up 0.5% of the total Earth mass. It is divided into 2 main parts. What are these 2 main parts that the Earth crust is divided to? We have the continent and the oceanic. You can see the continent and the oceanic. These are the 2 parts that make up the crust. So they both differ in their thicknesses, their density, and their composition. So if we want to distinguish the continent and the oceanic, then we make use of their thickness, their thicknesses, their densities, as well as what is their composition. Let us look at the continental crust. The continental crust ranges from the surface of the Earth down to about 30 kilometers to 50 kilometers. So from the surface of the Earth, which is 0 kilometer to 30 to 50 kilometers, we have the continental crust. We have the continental crust of the Earth. So the continent is largely composed of volcanoes. So there you often see volcanic eruption. Volcanic eruption is that region where is that continental part of the Earth where volcanic eruption takes place. It is also sedimentary in nature, and you also have some granitic rock. So the composition of the continental crust, we talk about they are volcanic in nature, they are sedimentary, as well as they are granite in nature. So you also see some granitic rock in the continental crust. When we come to the ocean crust, in the ocean crust, we are now moving from the surface of the Earth down to about 10 to 12 kilometers. So for the ocean crust, so from there, it shows that the ocean crust is shallower than the continental crust. The ocean crust is shallower than the continental crust. So the region between 10 kilometers to 12 kilometers from the Earth's surface, that's where we have the ocean crust, while the continental crust lies between 30 to 50 kilometers. We talk about the Moho. There are two hypotheses that shows that it is made up of two main parts. What are these hypotheses? One, there is a significant change in chemical composition. The composition of that layer, which is between the crust and the mantle, the chemical composition, the changes in their chemical composition is an evidence that that region is called Mo'o. And also, there is a phase transition. There is a phase transition between that layer. So a phase transition and the chemical composition, they are two hypotheses that that region is referred to as Mo'o. We also need to talk about, after the earth crust, we have the mantle. The mantle is thought to be primarily composed of ultra-basic rock, which are usually rich in magnesium and iron, and they are poor in silicates. So what are the mantle, which is next to the earth crust, is composed primarily of ultra-basic rock. And these ultra-basic rock are rich in manganese, as well as magnesium, as well as iron. However, they are poor in silicates. For the upper mantle, it is measured from the base of the crust down to about 400 kilometers. So the upper mantle, you can see the upper mantle in this diagram. We have the upper mantle, we have the lower mantle. So if this is projected, the projection of this radial structure of the earth in 2 dimensions now gives a projection of the upper mantle as well as the lower mantle. So when we talk about the upper mantle, we are looking at the distance from the base of the crust down to about 400 kilometers. And what are the composition? Unlike the earth crust, where it is only 0.5% of the Earth's total mass, for the mantle, it is 10% of the total mass of the Earth. And the density for the mantle varies from 3.25 gram per centimeter cube to 3.4 gram per centimeter cube. So the upper part is less dense and the lower part is denser. So the upper part closer to the earth crust has a density, an average density of 3.25 gram per centimeter cube, while the lower mantle is denser with a density of about 3.4. It is so because the iron contents of the mantle, more of the iron contents are found in the lower mantle. More of the iron contents are found in the lower mantle. That makes the lower mantle to be denser than the upper mantle. There is also a transition zone. There is a transition zone. This transition zone lies between 400 kilometers and 1,000 kilometers below the Earth's surface. it contains 17% of the total mass of the Earth. So the top of the transition zone is marked by a phase transformation. There is a phase transformation of normal olivine to protospinning structure, or what those in geochemistry they call polymorphism. There is polymorphism where there is transformation from the normal olivine. The third layer of the Earth is the core. When we talk about the core, we are talking about the outer core and the inner core. The core marked as the point within the Earth where Earth's wave cannot penetrate. Of all the three layers, the Earth's crust, the mantle, and the inner or outer core, what distinguishes the core from the other two layers is the fact that seismic S wave, which we call the shear wave, is not allowed to reach that layer. So the S wave, we are going to talk about the P wave and the S wave. The S wave, we call it the secondary wave, we call it the shear wave. By the time you are taking seismic in detail, you will look at these two waves. It is called S wave or shear wave because it travels only on the surface. The earthquake that happens, the collapse in building, most of these geohazard events, they are caused by S wave. When S wave travels on the surface, it leads to shaking. So when it shakes the earth, then anything above that part of the earth can come down. So when you get to seismic refraction or reflection, you will talk more about the S wave. So of the three regions, it is only in the earth core that seismic wave, or what we call shear wave or S wave or secondary wave, does not propagate. So it is believed to be composed primarily of nickel iron alloy consisting of a liquid outer zone and a solid inner zone. So the outer zone is liquid in nature, while the inner zone is solid in nature. So the outer zone, which is represented here by yellow color, is liquid in nature, while the inner zone, which is represented in white, is solid in nature. So the core is very rich in nickel iron alloy, and it also different from the other layer by an increase in pressure. That is an abrupt increase in pressure within that layer. So the outer core lies between 2,900 kilometers to about 5,000 kilometers. So if we want to distinguish the outer and inner core in terms of depth, then the outer core is shallower. The depth ranges from 2,900 kilometers to about 5,000 kilometers below the Earth's surface. For the outer core, it contains about 30% of the total mass of the Earth. The inner core is that layer that lies below the outer core. So when you are going to a depth that exceeds 5,000 kilometers from the surface of the Earth, you are now in the inner core, and it is characterized by its solid form. So it is beneath the 5,000 kilometer and 6,307 kilometer below the Earth's surface, with a composition of about 2% of the total Earth mass. So in a summary, The overall composition of the earth is dominated by elements such as iron, oxygen, silicon, magnesium, nickel, as well as sulfur. This is because most of the mass of the earth occur within the mantle, which is composed largely of magnesium, silicate mineral, the olivine, as well as the pyroxene. The core of the earth is largely composed of iron and nickel. We have just seen that. While the crust of the earth mainly comprises of minerals. The minerals that we can get there are the pyroxene, the quartz, then the hornblende, which is dominated by oxygen, silicon, aluminum, iron, calcium, sodium, and potassium. So that is as far as the structure of the earth is concerned. I won't bother you about the seismic portion. We have just only used the composition, chemical composition, and the depth to divide the earth into 3 or 4 layers. We can see that as the depth varies, then we are moving from one layer of the earth to another layer of the earth. Also, the composition of the earth, the mineral composition or their chemical composition, also tell us that we are moving from one layer of the earth to another layer. Another important aspect is using the seismic velocity. Using the seismic velocity. In order not to bother you so much with this, so I have decided to ignore that aspect, because that will be a course you are going to take in your year 3 when you get to year 3. For those that want to continue in geosciences department, it is a course you are going to take in year 3, seismic refraction and seismic reflection. You are going to take one in first semester and the other one in second semester. So how the seismic velocity changes from one layer of the earth to another, and that will enable us to explore groundwater in the subsurface for those who will be interested in seismic refraction or near surface geophysics. While for those who are inspiring to work in oil and gas, yes, if I mention oil and gas, I think majority of you guys, that is what you are gunning for, to work in oil and gas. It's unfortunate that only just a very small percentage of you guys will see yourself in oil and gas. That has always been the inspiration of everyone. Myself speaking with you, if anyone had told me I will come and hold a chalk or a marker, I will say it is you that will hold a marker, because I also had that belief that I will end up in oil and gas. So unfortunately, during my set, out of a class of about 28, only just 2 got a place in oil and gas. So oil and gas is not meant for everyone. In fact, the 2 that were in oil and gas, they are the least that everyone expected to be seen in oil and gas. That is God that does his work the way he likes, and no one can question him for that. So rather, I'm just telling you that, yes, during our own time, nobody gave us the idea that there are so many areas where one can specialize as a geophysicist. All of us were just aiming at oil and gas, but there are other very good areas that you can also be looking at: groundwater exploration, foundation investigation, which is actually making a lot of money now. You can look at the issue of collapse of building virtually everywhere. So the earth scientists are making money. The government has made it mandatory now. Before you put up a structure, you need to do geophysical survey of that site. So I'm just telling you now, so that you don't feel or behave the way I behaved during my own time. that as from your year one, don't have it in mind that yes, because you are in geosciences department, you must work in oil and gas. No, just very small percentage of you guys will be there. Don't worry, better orientation will be conducted by the past student for you guys, and they will tell you other aspects where you can start tapping in as you learn from your year one to your final year. So all of you guys cannot be accommodated in oil and gas. There are other aspects too that you should always pay attention to, where one can as well make money from. So I will not look at the seismic aspects of it, but we can use the depth, variation in depth, to classify the earth into 3 or 4 layers. We can also use the composition in terms of density, in terms of chemical composition, also to classify the earth. And we can also use variation in their seismic velocity. These are the 3 parameters that we make use of to classify. Aside that, their temperature also can be used, as well as pressure difference, the chemical composition, the depth, the temperature, the pressure variation. Essentially, the one that are very important, we are going to talk about the depth, which is what I've taken you through. We also look at their composition. Their composition also tell us we are moving from one layer to another layer, and also a variation in their seismic velocity. The seismic velocity, like I said, I will not look at that until when you get to year 3, when you will take seismic as a course in first semester, and also as another course in second semester. Maybe I think refraction will come before reflection. So refraction, for those that are going to be interested in near surface geophysics, somebody want to sink a borehole, you need to conduct geophysical survey, or there is investigation for mineral exploration, you use seismic refraction. But when it comes to oil and gas, one of the viable tools for oil and gas is going to be seismic reflection. So you will be taking through all that. So the choice will now be of yours to decide if you want to belong to near surface investigation, or you want to go to well-seated material, what we call borehole geophysics. Borehole geophysics, that is deep-seated structure in the subsurface. So the choice will be up to you as you get to year 3, you start learning some area of specialization, and you can choose any area that you feel is good for you. So what we did in the last class, which has to do with the solar system, the planet, 10 questions will be tested. The structure of the earth, 10 questions will also come to you. Your question is going to be a German, what we call German objective. What do we mean by German objective? It will not be A, B, C, D. No. For instance, the planets are divided into 2 main groups. 1 dash planet, 2 dash planet, the inner planet and the outer planet. That is how your question will come like. The Earth, the mass, are example of so and so planet. Mention 2 other planets that make up dash planets. Asteroid belts is a region that separates dash and dash. The internal structure of the Earth is radial in shape. It is made up of 3 main layers: dash, dash, and dash. A region where there is abrupt change in seismic velocity or where there is discontinuity in seismic velocity is called dash. The name of the scientist that found that layer is called dash. In what year? So this is how you are going to have your 10 questions. It means you just have to read between the lines. The Earth system is divided into 4 layers. The hydrosphere, the ozone layer, dash, and dash. So this is how you are going to see the question. You are going to write in the dash, dash, dash that will be given to you. So you will see 10 questions from the internal structure of the Earth. You are also going to see 10 questions from the universe and solar system as a whole.
Mr. Man,
Sir.
Yes?
Sir.
Yeah, I can hear you.
Is it the test or the exam?
Exam. The test will also take the same form, but I won't give you 20 questions in the test. I will just give you 5 questions in the test.
Sir, are you going to
5 questions will come from my part. 20 questions will come from my part. Since you have 6 lecturers taking, 20 questions will come from my part in the exam, for the exam. 5 questions will come from my part for the test.
Sir, that's 100 questions for exam.
For
exam.
120 questions. 6 of us are teaching you. 120 questions in 2 hours. You can ask last year's students, you can ask them. Unfortunately, this course is taken in 2nd semester. You can ask them, they took it in 2nd semester. Unfortunately, you may not have past question because you are going to write in it and you submit. So, but you can ask them, they will tell you the form in which the question takes. They took it in their 2nd semester last year, but you are taking, because of the change in the curriculum, you are taking it in your 4th semester.
Okay, sir.
So just make sure you read between the lines. Things I wrote in the whiteboard, note all those things I wrote in the whiteboard, as well as this slide. So when I update this slide, hopefully today, before today or tomorrow, I will send it to the platform or your class rep. She will send it to all of you. So I just want to update it to include what I taught you about the solar system. So just read between the lines of what I've written in the whiteboard and what you have in the teaching material. So that will inform your question. Okay, so with this now, I want to go back to introduction to geophysics. I've completed this. I want to complete introduction to geophysics too, so that somebody else can start teaching you as from next week. I don't want to. You said? No, this class, this one is physics of the earth. Okay, somebody else is teaching you that. Okay, if that is so, no problem.
Someone else is teaching us, sir.
Yes?
Sir, someone else is teaching us, but it's not this week. Next.
Someone else is teaching you next week, not this week.
Yes, sir.
Oh,
But
I
you are
thought
not
you
done
said
with
something.
yours now.
You said?
You are not done with your own part, sir.
Yes, that's what I want to switch to now. I want to switch to introduction to geophysics now, so that
Okay, sir.
I can conclude my part and someone else can pick it up next week.